Thank you so much for that introduction and, of course, for the invitation to speak today. As mentioned, my name is Nancy, and I'm the outreach coordinator for Reactome. And today I really want to tell you about how our team is leveraging large language models for enhancing biocuration and the user interactions with Reactome. So for those of you who are not too familiar with Reactome, Reactome is a project that was created 22 years ago. And Reactome was really born out of a lack of centralized resources for collecting known molecular pathway information. So currently we have 2,698 human pathways in Reactome. And this has been broken down into 15,000 individual reactions. And all of this comes from literature references, of which we have around 38,000. So the way that Reactome currently works is that the curator will manually curate known pathway information from the literature, recruit outside experts for peer reviewing, and then after those revisions, they enter the database. So as you can imagine, this is a very time-intensive process. For the user, this information is accessible in a variety of different ways. So there are more general illustrations. There are granular pathway diagrams showing individual reactions. We have summations that accompany each of the pathways and the individual reactions, and these are written by curators manually. And then we have analytical tools and visualizations for users who want to understand their own data set in the context of Reactome pathways. So I really want to tell you two stories about how we're augmenting these processes. So the first is really the curation side. And we're currently working on enhancing our curator tool to streamline that curation process. So currently, curators have to find information on their own using PubMed or other databases. But what we've created is a LLM model that allows us to enter a gene that's not currently annotated in Reactome, and then it will go to PubMed to search for literature that contains that gene. And we also feed this into Reactome IDG, which is another project we've published a few years ago, which will predict interacting pathways and interacting genes based on what's within Reactome. So this information is then put together and placed in an LLM to summarize those pieces of literature and create a summary for the curator. And the idea here is really to accelerate and scale our curation process, allowing curators to do decision-making rather than the manual work of looking at the literature. So here's an example of what this looks like. The curator will put in a gene like TANK1, for example, which has not been annotated in Reactome. It produces a summary for that query gene, and it generates links to literature using a RAG model. Relevant details about that gene and the pathway they're collected and summarized, including the identified literature. And then it also predicts individual pathways where that gene or protein might be interacting. And again, the relevant sources from the literature is displayed for the curator. So what we're really hoping to do here is to augment our curation process and allow for a more scalable version of our curation model. And this opens up a potential for curators to perform more fact-checking rather than performing the literature summation. And as I said, we're also looking to leverage LLMs to improve the user experience. And this is something that we're working actively on deploying soon for the public to try out. So currently with the Reactome user experience, the process really begins with the search bar. You may come to Reactome and put in a molecule that you're interested in. So for example, GATA6, and you'll see that there's 95 different search results in Reactome. And if you open up where the pathway browser, where this intersects, again, there are many, many examples of where GATA6 appears. So if I'm a user who wants to understand broadly what GATA6 does, I would have to look at a summation of one pathway, then the next, and so on. And so to address this, what we're working on is a new feature. We're building a chatbot that answers these questions more directly. So for example, I can say, explain the role of GATA6, and it'll give me a text response that integrates all these different ideas, including links to where it appears in Reactome and sources where you can read more about it. So right now, as I said, it is a prototype, so we're still working on understanding whether it's performing as expected. So we've tested its faithfulness, context relevance, and answer semantic similarity to the data that we provided. And we're looking to roll out an alpha version of this in the coming months. So if you're interested in trying out the product, please let us know, and we can give you an early sneak peek. So just lastly, I want to say thank you again for your attention, and to the organizers for the invitation to speak. The work here is not possible without our team, our contributors, our reviewers, collaborators, scientific advisory board, and of course the funding that comes from NIH, ODSS, and NHGRI. Thank you.